What's up guys, it's Simon Fiaz and today's video is on AQA level chemistry rate equations question paper from physics and maths tutor. Only a couple more of these video walkthroughs left. Yeah, only a couple left. And then during the half term, or actually before the half term, I will maybe during the half term I'll find all the difficult questions, past papers that I find difficult, go through those, and then it's exam time after May half term. So yeah, question 1: solution of two compounds W and X react together in the presence of soluble catalyst Y is shown in the equation. When the concentration of W and X and Y are all doubled, the rate equation increased by a factor of 4. Which is a possible rate equation for this reaction? Rate equation considers the reactants. So it can't be D. It also, okay, now if we look at A and B, with the thing about A is if you double W, that'll be 2 squared times by 2, it increased by a factor of 8. Same thing with this one. If you increase that, that's double, that increased by a factor of 4, therefore it must be C. Question 2, say show how these data can be used to deduce a rate expression for the reaction between A and B, and it is 3 marks. So it doesn't want me to calculate anything, it wants me to show how this data can deduce the rate expression. Well, that increases by a factor of 3, and what happens to the rate equation? Well, if I do that divided by that, increase it by a factor of 9. So that tells me A is, with respect to A, it's second order. So let's look at that. So I'm going to say consider experiments 1 and 2. And if you consider experiments 1 and 2, you can see that concentration of B is constant and concentration A is second order. And then obviously you say how, because that increased by a factor of 3 but rate increases by a factor of 9, therefore it must be squared, but you can always say that. Then I also want to consider reaction 2 and 3. So I consider experiments 2 and 3. What can I see? Well, that doubles. That, well, that's halves. 0.13 divided by 0.26 is a half. So that halves. And this, 3.78 times by 10 to the power minus 3 divided by 1.89 times by 10 to the power minus 3 doubles. Okay, so that's interesting. So if A is respect to power 2 squared, which is 4, and I want to get 2, if I do 4 times by 1 over 4, I get 1. Or if I do 4 times by 1 over 8, I get a half. But if I do 4 times by a half, I get 2. So I should just send that first. So consider experiments then 2 and 3. And what do you spot? And therefore it's a half, the order is a half with, oh sorry, first order with respect to B, because you times that by half, you get 2, so it's just the same, it's just that first order with respect to be. So the rate expression, rate equals K, bracket A, where we decided that it's second order, times by the concentration of B, which is obviously first order, but you can leave it like that. And that's it. Use the data from experiment 4 to calculate value for the rate constant K, introduce the units of the K. K equals rate over C squared times by D. Just be careful, it tells me use data from experiment 4. So I'm just going to highlight this just to make it clear. That's the data I'm going to be using for this part of the question. So the rate is 7.2 times by 10 to the power minus 4 divided by C, 1.9 times by 10 to the power minus 2 squared times by D, 3.5 times by 10 to the power minus 2. So 7.2 times by 10 to the power minus 4 divided by 1.9 times by 10 to the power minus 2 squared times by 3.5 times by 10 to the power minus 2. I get 57, and the unit, so it's going to be the rate unit is mole per dm minus cube s to the power minus 1 over mole per dm minus cube cubed. Well, that will give me s to the power minus 1 over mole dm minus cube squared, so mole to the power 2 dm to the power minus 6. And then that would give me s to the power minus 1 mole to the power minus 2 dm to the power 6. So let me just write as mole to the power minus 2 dm to the power 6 s to the power minus 1. Calculate value for the initial rate in experiment 5. Well, the initial rate in experiment 5 is K C squared D. So all that's going to be the rate equals 57, which we just worked out, K, times by this squared times by this. So it's going to be 57 times by 3.6 times by 10 to the power minus 2 squared times by 5.4 times by 10 to the power minus 2. And you get 3.99 times by 10 to the power minus 3. And I guess you leave it like that. The rate equation for reaction is this. Explain qualitatively why doubling temperature has a much greater effect on the rate of reaction and doubling concentration of B. Well, what you need to spot is the wording. Much greater effect on the rate. And this is what during the half term where, I'll be going through these kind of questions where you need to know these key terms where then you switch your brain into a different mode from, okay, so we're going to have to think like this. So first things first, reaction happens when what? When molecules have energy greater than or equal to the required activation energy. Doubling temperature by what? 10 doubling temperature causes many more molecules to have this energy, whereas doubling the concentration of E only doubles the number with this concentration of E. So reaction happens when molecules have energy greater than equal to required activation energy. That part, okay, that's fine. But doubling temperature causes, and you need to state this, many more molecules. Many more molecules have this energy, whereas doubling the concentration E only doubles the number with this E, and therefore doubling temperature has a much greater effect on the reaction, doubling concentration E. A slow reaction has rate constant this at this. Use equation to calculate value for activation energy. It tells me ln K equals ln A minus EA over RT. So let's rearrange it. EA over RT, EA over RT equals ln A minus ln K. Therefore, EA equals ln A minus ln K times by RT. And I want the activation energy in kilojoules. What is activation energy usually measured is usually measured in joules. So let's substitute the values in. R is 8.31, obviously, times by 2.57 times by 10 to the power of 10, bracket ln A, 2.57 times by 10 to the power of 10, minus shift ln K, where K is 6.51 times by 10 to the power minus 3. I get this value in my calculator, but then I need to divide by 1000. And then I get okay, I think I've done something wrong here. So temperature 8.31 times by 300 ln A 2.57 times by 10 to the power 10 minus ln K 6.51 times by 10 to the power minus 3. Yeah, and then divide by 1000. 72.3. But let me just, sorry guys, I just want to make sure that I'm not doing anything wrong. ln A 2.57 times by 10 to the power 10 minus shift ln K 6.51 times by 10 to the power minus 3. Yeah, okay, it's fine. I get 72.3. Kilojoules multiplied mass 1. Question 3, the expression for the reaction between x and y is this. Which statement is correct? Ooh. The rate constant has units multiplied minus 1 dm cubed s to the power minus 1. The rate constant K equals, well, it's going to equal rate, which is mol per dm minus cube s to the power minus 1 over mol per dm minus cube, and that will cancel out, and then you get K. You get the point. S to the power minus 1 over mol to the power 2 dm to the power minus 6, and then you would get, yeah, you wouldn't get that. We've decided that. Part B, the rate of the reaction is half if the concentration of X is half and the concentration of Y is double. Just substitute your values in. A half squared times by 2 gives you a half. The rate of reaction is halved. Yes, it is. Therefore, it's B. Question 4. What is the initial concentration of Q in experiment 2? Which is this. I'm giving, well, that increases by a factor of 3 times by 3. That doubles. And this is to be calculated. And I know P is first order, Q is second order. Okay. Well, I'm going to say 3 times by, let's say this imaginary thing is K. 3 times by K equals 2. But it's not K though, is it? It's K squared, because it's respect to 2. So times by k squared equals 2. K squared equals 2 over 3. K equals square root of 2 over 3, which is root 6 over 3. And now if I do that, I do 0.500 times by my answer, I get 0.408. And that is your answer. But Iman, don't you times by 2 over 3? Because that's what he said. No, it says the initial concentration of Q. It doesn't want Q squared. Q is to respect order of second order, but it just wants Q by itself. So it is 0.408. Therefore, the answer is C. Question 5. What was the pH of the second mixture? The rate equation for the acid catalyzed reaction between iodine and propanone. Rate of reaction was measured for a mixture of iodine, propanone, and sulfuric acid at pH this. So immediately I can find out concentration of H plus ions. I haven't done acids and bases in quite a while. This is so I think that's going to be the one tomorrow. Acids and bases question paper. Yeah, definitely that one tomorrow. So it's 10 to the power minus 0.70. In the second mixture, the concentration of ferric acid was different, but the concentration of iodine. So let's read it again. The rate of reaction was measured for a mixture of iodine, propanone, and sulfuric acid. In the second mixture, the concentration of sulfuric acid was different. So this was different, but the concentration of iodine and propanone were the same, unchanged. The new rate reaction was a quarter of the original rate. Well, I found out the concentration of H plus ions, and I know in the second mixture, the concentration of the sulfuric acid was different, but everything else was the same, and the pH was now a quarter of the original rate. What was the pH of the second mixture? I don't know why there's so many multiple choice questions here, but this one definitely is a tricky one. But it tells me in the second mixture only concentration of ferric acid is changed. But what does that mean? Sulfuric acid, that tells me that's the H plus ions obviously, and therefore the concentration of H plus ions was changed. And therefore what's the pH second mixture? Well, pH, the formula of pH is minus log 10 H plus. And I know the rate of reaction was a quarter of the original rate. So what does that tell me to the H plus ions? It's times by a quarter. Reason being is because only the H plus ions changed. And the question is say concentration of ferric acid, yes, but that was the H plus ions. So it's going to be 1 over 4 times by 10 to the power minus 0.70. And then you substitute that into minus log 10 of your answer, and you get 1.30. Therefore, the answer is B. Question 6. Suggest whether 1 cm cube of hydrogen excess the sodium hydrogen carbonate solution neutralizes the acid bracket catalyst. Sodium hydrogen carbonate solution neutralizes acid bracket catalyst, hence stopping reaction. suggests whether orders with respect to propanone can be ignored. Anytime you see orders, you see this, orders ignored, it's always to do with the amount of what you have. Well, I know I've got 25 centimeters cube of 1.0 moles per DM minus cube of propanone, but then I've got 10 centimeters cube of 1 mole per DM minus cube of HCl, and then the iodine, and I've got iodine and propanone, but look at the concentration of iodine. 5.0 times by 10 to the power minus 3. Okay, so that's the reason, because the concentration of propanone is much larger than the concentration of iodine, hence the concentration of propanone is constant. Concentration of propanone is much larger than concentration of iodine. Concentration of propanone is constant. It says, you draw your graph, and draw a line of best fit. So you know how to do this. Plot it, and then you just draw your line of best fit, straight line of best fit. Pretty nice 3 marks. I'm not going to fill in the axes. Explain how the graph shows that the reaction is zero order with respect to iodine. So yeah, that's why you have to do this. Let's say you skip this part and try to move on. Well, you wouldn't be able to, because how the graph shows it is because it's a straight line. Well, the graph is a straight line, hence has a constant gradient, so the rate of reaction does not change as the concentration. Actually, we can just say, so the rate of, so the iodine is being used up at a constant rate. Part E, calculate for activation energy, use this graph, 3 marks. Okay, how would I do this? Well, what is this? If I ask you guys, what is this? You're going to tell me it's a straight line. Straight line. And then I ask you, what's the formula of a straight line? From GCSE, y equals mx plus c. So let's compare it to this. So I've got ln k equals minus EA over RT plus ln A. Y equals mx plus c. So I know c is that, y is that. What's m? M is minus E over R, x is t. So m equals minus EA over R. So that's really important. And then I find out the gradient. Let's say I get the gradient as minus 21731. 21731 minus 21731 equals minus EA over R. Negatives cancel out. You get EA equals 21731 times by 8.31, and then you need to divide by 1000 because you want it in kilojoules. And you get 181 kilojoules multiplied by minus 1. Finding the gradient, just watch a couple of videos, watch a walkthroughs, but yeah, it's just y2 minus y1 over x2 minus x1. Use a graph in figure 1 to determine the initial rate of reaction for the experimental status units shown working on the graph. Initial rate of reaction. Well, because I see initial rate of reaction, I'm going to draw a tangent drawn to the curve at 0, 0, and then just find the gradient. So just draw a tangent to curve at 0, 0, find the gradient, and then that's it. And you should get wherever your value is. You should get the initial rate as 5.8. The units. What would be the units? Would be the units. Well, it's going to be centimeters cubed per s. But the s, because I want the rate, s is centimeters cubed s to power minus 1. Not centimeters cubed. Not centimeters cubed s. That's a very easy mistake to make. Very easy mistake. But yeah, please don't make that mistake. Don't. It's centimeters cubed s to power minus 1. Say the relationship between initial concentration of phosphonate and time. What does it mean by that? Phosphonate and time. Well, I can see that this, I can see this literally is doubling. 4 times 2 is 16. You're doubling that as that decreases. So the relationship, the order, that's not going to be a problem. But the relationship, well, let's have a look. If concentration doubles, what happens to time? Time is quartered from 64 to 16. So what you could do is you could say H2PO2 minus is inversely proportional to 1 over T. But I don't think I don't think I would do that. I think I would just say as concentration doubles, time is quartered. So what is the order now with respect to phosphonate? With respect to phosphonate. So, well, that's clearly going to be then the order is going to be 2 then. Order is going to be 2. Yeah. Complete diagram figure to show how the hydrogen gas could be collected and measured. Well, you're going to need your gas syringe. So from here, and then your scales in here. And this is obviously your gas syringe. What is this called? This is called a conical flask. And what is this? This is your mixture. Well, let's be more specific, your reaction mixture. And was that all for 1 mark? I think it was. Yeah, and then part D, deduce the overall effect on the rate of reaction with the concentrations of both above L and M are halved. Well, L's halved, going to be a half times by a half squared, which is 1 over 8. So then you can therefore say the rate of reaction decreases by a factor of 8. So you can say, you could say this 2 ways. You could say falls by a factor of 8. But that is technically the same, falls by a factor of 8, but that's technically the same thing as multiplied by 1 over 8. So falls by a factor of 8 or multiplied by 1 over 8. Anything is fine. Derivative reaction is this, calculate concentration of M. Okay, M is here, so I need to rearrange it. So concentration of M equals rate divided by K times by the concentration of L square root. So I'm just going to substitute in, honestly, because we've got a lot more questions to do. Don't want to waste any time. So square root of rate, which is 0.0250 divided by K, 0.0155 times by 21.3 0.275 0.275. Define the term overall order of reaction. Finally, a definition question for 1 mark. I thought it'd be 2, but okay. 1 mark. The sum of powers to which the concentration. Okay. The sum of powers to which the concentrations are raised to in the rate equation. Sum of powers to which concentration raised to in the rate equation. Now you could try and not learn these definitions and then hope in the exam it doesn't come up. But if it does, then who can you blame? You can't blame anybody else except for yourself. Sum of powers to which concentration raised to in the rate equation. But you still have plenty of time. You have a full month, a full 30 days until, I think, at least a full 30 days to the chemistry paper 1, so that's fine. Name the process that's prevented by cisplatin during cell division. DNA replication. Yes, it is that. DNA replication. Give the equation for this reaction. After cisplatin enters the cell, one of the chloride ligands is replaced by a water molecule. So one of the chloride ligands. So after cisplatin enters the cell, so you've got cisplatin, and then you're adding water and you're forming a complex ion where one of the chloride ligands is replaced. So it overreacts what you need to actually do. All it's really saying is cisplatin enters the cell. You're adding water and you're forming a complex ion where one of the chlorine ligands is replaced. So it's just going to be PTNH3 2Cl, and it's replaced with what? Replaced with a water molecule. H2O plus Cl minus. Overreacting, definitely. It's not too complicated. Complete figure 1 show how the platinum complex forms a cross-link between the guanine nucleotides. The platinum cross-link, so you've got platinum, which is here. But what does platinum have? You have NH3, H3N, and then you've got the nitrogen with the lone pairs of electrons. Then it goes to here, and it goes to here. During the experiment, the concentration of cisplatin is measured at 1-minute intervals. Explain how graphical methods can be used to process to measured results to confirm this reaction is first order. Plot concentration against time and take tangents to calculate the gradient. Plot the gradient, which is the rate against concentration, and then straight line through origin confirms that reaction is in fact first order. Complete the table above. Just copy it straight from the mark scheme. I just want you to fill it in. Well, 1 over t, 1 over this, ln k, ln of this. As long as you know how to use which you do have to know how to use the ln function. And obviously on order to use it needs to be in a scientific calculator. Calculate activation energy in kilojoules multiplied minus 1. Oh, okay, he wants me to plot a graph and then calculate the activation energy. How would I do that? Well, again, once you plot the graph, what you notice, I'm just going to copy it straight from the mark scheme, you should get like something like this. Straight line, get a straight line, right? You know, the plotting of the graph isn't the main thing that it's assessing. Obviously, that's a skill as well. But once you plot the graph, it's then knowing that it's a straight line, and therefore that straight line represents y equals mx plus c. And therefore, if you've got this, and you compare it to y equals mx plus c, you know y is ln k, c is ln a, m is minus e over r. So m equals minus ea over r. So I get the gradient from the mark scheme minus 13,125. 13,125, well, equals minus ea over r. What do you notice about negatives? Cancel out. Ea equals 13,125 times by 8.31. But what is activation energy normally measured? Is normally measured in joules. So then I also need to divide by 1,000 to get 109 kilojoules multiplied minus 1. And that all of that is for 5 marks. Question 9, calculate value for the Arrhenius constant A. And it gives me this, calculate give the units for A. Okay, calculate A. How would I calculate A? Let me write down the Arrhenius equation. K equals AE, K equals A e to the power minus EA over RT. K equals AE to the power minus E over RT. I take ln K, so you need to convert into logarithmic form. ln K equals ln A minus EA over RT. Because if you do ln of E, that cancels out anyway. Then move that to right left hand side. So ln A equals ln K plus EA over RT. Find A equals whatever my answer is, E to power whatever my answer is. So shift ln K is 3.46 times by 10 to the power minus 8. Plus activation energy measured in joules, 96,200 over 8.31. And then I do shift E to the power of my answer, and I get a maths error. So I've clearly done something wrong. So you get ln A. So ln A equals shift ln K. 3.46 times by 10 to the power. Is that minus 8? Yeah, minus 8. Plus EA 96,200 over RT, which is 25, but I need to go into Kelvin, so 25 plus 273. Okay, then I get Then I get what I need to get. Then I get ln A equals 21.667. A equals e to the power of that. So shift e to power my answer. I get a ridiculously large number, 2.57 times by 10 to power 1, 2, 3, 4, 5, 6, 7, 8, 9. And the units, what would be the units? Well, it's just going to be s to the power minus 1. And let me write that down. I just need to double check a couple of things, whether that applies to every single case of the Arrhenius constant. Is the Arrhenius constant always? The units s to the power minus 1, so I'm just going to jot that down as something I need to do. Is Arrhenius constant A always s to the power minus 1? I'll double check that later, but for this case it is. Use data from experiment 1 and calculate value for the rate constant K. So, well, before you do that, you actually no, you don't. So this is again, it's the same process. K equals rate over what you get, BR O3 minus times by BR minus times by H plus squared. And that's it. That would give you K, 13. The units, though, is definitely, I think the units is the hardest part of these kind of questions, where it's like calculate rate constant K, and then give the units. The units is where most should probably trick up on. Well, the units is mole per dm minus cubed s to the power minus 1. Just write down the units over what? Mole per dm minus cubed to the power 2, 3, 4. That would cancel out. So you would get s to the power minus 1 over mole to the power 3 dm to the power minus 9. So you'd get mole to the power minus 3 dm to the power of 9 s to the power minus 1. And it doesn't matter which order you do it, it can be in any order. Any order is fine. But I would just prefer to do it like this, where it's mole, then dm, then s to the power minus 1. Complete table 1. Okay, well, let me just get rid of all of this now, because there are quite a few gaps. There's how many gaps? 3? Okay. So how do I approach this? Well, I know all of these two are first order, that's second order. And I know, let's compare reaction experiments 1 and experiments 2. Experiments 1 and 2, that's constant, this, what does that increase by? Do 3.6 times by 10 to the power minus 2 divided by 2.4 times by 10 to the power minus 2. And that would give you 3 over 2. Over 2. And I know BrO3 minus is first order, so it's just going to be 0.10 times by 3 over 2, which is 0.15. 0.15. Then experiments 2 and 3. Well, that increases by what? That increases by what? That increases by what? Okay, let's get rid of everything else. I know that's 0.15. Now I'm considering experiments 1, 2, and 3. Well, 0.20 divided by 0.15, 4 over 3 times by 4 over 3 times by 2, 1.5 over divided by 0.30 times by 5 over 3. But h plus is squared, So it's not actually times by 5 over 3. It's the square root of 5 over 3 squared. So then I'm going to say it's 4 over 3 times by 2 times by my answer. And then I'm going to do 3.6 times by 10 to the power minus 2 times by my answer. 0.124. Okay, that's clearly wrong. 5 over 3 times by 2 times by 4 over 3. 6 times by 10 to the power minus 2 to my answer. Experiment 3, the rate should be 0.26. How'd you get 0.26? Okay, well 0.15 to 0.20 is 4 over 3. 0.20 divided by 0.15 is times by 4 over 3. 0.40 divided by 0.20 is times by 2. 0.50 divided by 0.30 is 5 over 3. Right, initial rate of reaction is 4 over 3 times by 2 times by 5 over 3 squared, and then 3.6 times by 10 to the power minus 2 comes by my answer, 0.26. Okay, so you do actually, that is squared, so you times it by 5 over 3 squared, and then experiments 3 and 4, that's times by half, that's times by 1 over 4, and this final one, 2.7 times by 10 to the power minus 2 divided by 0.26 is times by 27 over 260 times by 27 over 260. So I got a half times by a quarter, which is obviously an eighth. So an eighth k, but hit constant h plus is squared equals 27 over 260. 27 over 260 times by 8, and then do 0.50 times by my answer. So, and then you get a 27 over 260 times by 8, square root your answer, and then do 0.50 times by answer, 0.46. But in this case, you had to square root your answer, because that is k. You know what I mean? But in this case, initial rate of reaction, yeah, well then you're going to include 5 over 3, which is squared, because it says that there, that's why. But in this case, you want to find out concentration H plus. So it's not going to be 5 over 3 squared, it's going to be whatever that is, which is just k. So you need to then square root your answer. That's the tricky part. Complete table 1, yes, nice. I guess nice 3 marks. Complete table 2. It should be ln 1 over t is minus 3.30, and 1 over t is 3.31 times by 10 to the power minus 3. Six marks, and it's not a nice question, is this? It says the Arrhenius equation can be written as this. In this experiment, the rate constant k is directly proportional to 1 over t, where C1 and C2 are constant. Use value from table 2 to plot a graph of this against this. Table 2 is here. So I want to plot ln 1 over t against 1 over t on the grid, and then use a graph to calculate value for activation energy in kilojoules multiplied by -1. but this is the Arrhenius equation. Okay, yeah, they've just tried to make it, I guess, scarier. But if you just face the question head on, you know that's y equals mx plus c. That's what you're gonna get. Well, not for this case. It's gonna be for this case, and therefore m equals minus ea over r for both of them, and therefore minus ea equals m times by r, and then minus ea equals m times by r divided by 1000, and yeah. So you plot your graph, which I ain't gonna go through. Well, ln 1 over t is your y-axis. It tells you that, so you just plot ln 1 over t, and then you plot your points. You get a straight line, then you remember y equals mx plus c. This is what Iman said. If you see a straight line, which you will see a straight line because there's no other way about using a gradient or that. Y equals mx plus c. Then you get the gradient. You just y2 minus y1. You get the gradient as like minus 6.64 times by 10 to the power 3. And then what you notice is the negatives cancel out, and you get EA equals that times by 8.31 divided by 1000. It's the same thing every time. I think we've done like 3 of these where it's literally the same thing. But the only thing different is, one sec, you get 55.2. 5.2. The only thing different is that they try to kind of scare you with this C1, where you're normally maybe familiar with ln k equals ln a minus EA over RT. But instead of minus EA over RT, they've written it as minus EA over R times by 1 over T. It's the same thing. And then you do the same exact method. Plot the graph, straight line, y equals mx plus c, gradient is minus E over R, compare them, and then, yep, times by R, negatives cancel out, and always check the units, and this case divide by 1000. Explain by the use of a large excess of H2O2 and I minus means that the reaction fixed temperature depends only on concentration H plus. Aqueous. Well, the idea that H2O2 and I minus concentration, therefore, is constant, so have no effect on the rate. Or you could say, so is zero order. Whatever you prefer. H2O2 and I minus concentration constant, therefore no effect on the rate, or zero order. So it was explained must be done to each sample was titrated alkali. Stop the reaction. The reaction by dilution. Then how the graph shows that the order with respect to H plus 0. Obviously going to be talking about constant gradient. But I would always say straight line. Straight line graph represents constant gradient. And with respect to H plus, well, as the concentration of H plus changes / decreases, it represents a constant gradient. Concentration, so I need square brackets there. Very specific, these masking, so yeah. Calculate value of K1, give the answer K1. Well, K1, what's K1 going to be? Tells me this. Where H plus C is that. So K1 is the rate. K1 is going to be the gradient, therefore. So you just find the gradient, delta y over delta x. You get K as 1.2 times by 10 to the power minus 3. And again, a very simple mistake. Multiply minus cubed s. There you go. Well, that would lose me a mark because that's not the answer. is multiply a minus cube s to power minus 1. Part E, plot these results on the figure. I ain't gonna do that. You just plot in the results and then draw a line of best fit, and then draw a line of best fit. But what you notice about this, therefore, I'm gonna just quickly do it now, is that it's not gonna be a straight line, is it? It's gonna be a curved line of best fit. Obviously, I don't plot it accurately, but you should identify as a curved line of best fit. It's not a series of straight lines between points. Calculate wave reaction concentration plus is 0.35. 0.35. And then you just calculate the gradient. Draw a triangle, y2 minus y1, x2 minus x1. And the rate is 4.09 times 10 to the power minus 4. These are like specific methods you need to know. Maybe watch a couple of YouTubers walkthroughs, and then obviously maybe do one example, but you don't really need to, I guess, for these graphical questions. Actually, maybe yes, you do. Maybe you do. And then part H. A general equation for reaction is shown. They're all colorless, but E is dark blue. A region X is available that reacts rapidly with E. This means if a small amount of X, including initial reaction, makes it react with any E produced until all the X is being used up. Then given brief experimental details, use the same experiments to determine other reaction with respect to A. Stage 1, preparation. Measure suitable volumes to determine the order's reaction with respect to A. Well, I've only determined the order. I'm going to have to sketch a graph. In order to sketch a graph, I need to first find out suitable volumes of A, B, and C. Use of colorimeter to separate containers. And then stage 2, my procedure. So this is a preparation. That was the preparation of it. Procedure: start timer at the point of mixing. Take series of colorimeter readings at regular time intervals. Use the same concentration of B and C at the same temperature, but repeat with different concentrations of A. And then stage 3, plot absorbance, because that's what the colorimeter is for, absorbance. Plot absorbance versus time and calculate gradients. And calculate gradient at t equals 0 because I want the initial rate reaction. Plot of gradient against volumes of A, and then you interpret the order. So if it's a straight line, if it's like this, if it's like this, then you find out that, and you show that in the exam. And that is the end of this PMT question paper. Wasn't too difficult. I guess this last practical question was maybe slightly difficult, but yeah, it's just exposing yourself to these kind of questions where it's like 6 marks. 6 marks just for this, where you just have to plot your graph, and then we'll use y equals mx plus c to find a gradient, and then all of that. Which is very nice. But trust me, they're likely to reuse these kind of questions because why not? Because there's a lot of little tricks you need to know as well. But anyway, that is the end of the question paper.